Alright, so now I'm going to show you how to solve some logarithmic equations. First one's pretty simple. Natural log of x equals 2. The first thing you want to do is what's called exponentiate each side. So, e to the ln x equals e to the 2. I put both sides as exponents to the value e. Now, I can basically just solve this answer. I know that e to the ln x is defined as x. So x equals e squared. And at this point, you can just use your calculator to figure out each side. This property is called the inverse property, in case you couldn't remember it. All right, let's try solving this logarithmic equation. Now you'll notice both sides have log base 3. That's important. This value here must equal this value here. Well, that's an easy solve, so let's just do 5x minus 1 equals x plus 7. Solving for x, how about 4x equals 8? X equals 2. So, those are the two answers. So, let's do some solving of logarithmic equations again here. First thing we want to do is move the 5 to the other side. So I'm going to rewrite this 2 ln x equals negative 1. Divide by 2. Ln x equals negative 1/2. At this point, I want to do what's called exponentiate, or write both sides to the same base. So, for this one here, for ln x, I write e to the ln x. On this side here, I do e to the negative 1/2. Now, the cool part about this is that's one of the rules that you had to learn, and e to the ln x is e, so x equals e to the negative 1/2, and you can type that right into your calculator and get an answer. You know what that is? Hopefully, you know that it's 0.607. All right, let's do one more. Ready? On this one, first thing we'll do, divide by 2. Log base 5, 3x equals 2. That was no big deal. Now, let's exponentiate again. In this one, since this was a ln, we used base e because base e is understood. What base should we use to exponentiate here? We should use the base 5. So 5 to the log base 5, 3x equals 5 to the 2. So I used a base of 5 for each side. Now, by that same log rule, this answer is 3x equals 5 squared, 25. So x equals 25 over 3. So the cool thing to remember, if the problem is in base 5, you use the base on both sides and raise both sides to the exponent. If this was a base 8, then I'd use an 8 for both of these numbers. All right, let's try this problem. Notice there's two parts here on this side of the equal sign, so I'm going to use my log rules to combine that into one part. So log base 10, addition of two logs means I can write them as a multiplication. So I have 5x times x minus 1. Let's make that a square bracket so that it's easier to read. Equals 2. So I use log rules to combine those two things. Now at this point, what do I want to do? Exponentiate to the 10. So this side is going to be to the 10. This side's going to have a base 10. I'm going to put 10 squared over here because of that 2. What am I going to put over here? This whole amount here. So log base 10 of that bracket, 5x times x minus 1. And then, remember the inverse property? If this is 10 log 10, this value can equal that. So, 5x times x minus 1 can equal 100. At this point, I can move the 100 over. So let's get some more room up here. If I move the 100 over and multiply this out, I get 5x squared minus 5x minus 100 equals 0. Right? I could factor that. Before I do, I notice everything divides by 5. Let's make our work easier. X squared minus x minus 20 equals 0. And then I can factor x minus 5, x plus 4 equals 0. So x equals 5, x equals minus 4. Now, both of these could be answers. When I check these answers, though, and where do I check them? Way back in the very beginning, right? When you check them, you find out that minus 4 can't be an answer and only 5. Why? Minus 4 in here makes this part of the log a negative, and that's not possible. So when that happens, you have to exclude that answer. So be careful with these.